In the fifth book of Euclid, we dealt mainly with ratios, which are not fractions. However, fractions contain the same information that ratios hold, so it turns out we can replace ratios with fractions and prove the same results. We found that the fifth book of Euclid contains proofs that were tedious and it was easy to get lost from the big picture. This video will run through the same propositions but with fractions instead. This will give us a big idea, simple picture of the fifth book of Euclid. We will only look at propositions that deal with proportion and skip the ones that deal with the definition of proportionality. First, we have proposition 5.4. If A over B is equal to C over D, then equal multiples of the numerators over equal multiples of the denominators are also equal. This is easily seen by substituting the equal multiples with their part counterparts, and then canceling out the n and m's. Jumping to 5.7, if A is equal to B, dividing by C preserves the equality, and dividing C by A and B also preserve the equality. In 5.8, we do the inequality equivalent. If A is greater than B, dividing by C preserves the inequality, and dividing both sides by AB and multiplying by C also preserves the inequality. The inequality doesn't flip because all the numbers are positive. 5.9 is the converse of 5.7, that if A over C equals B over C, then multiplying by C shows that A is equal to B, and if C over A is equal to C over B, then multiplying both sides by AB and dividing by C also shows A is equal to B. 5.10 is the converse of 5.8. If A over C is greater than B over C, then multiplying by C shows A is greater than B. And if C over B is greater than C over A, then multiplying both sides by AB and dividing by C also shows A is greater than B. 5.11 says that if A over B is equal to C over D, which is equal to E over F, then A over B is equal to E over F, which is self-evident. In 5.12, given a set of equal fractions, the fraction made by adding all the numerators together over all the denominators together is equal to those equal fractions. To see this, take the equations and multiply both sides by b and b plus d plus ... plus I to remove the fractions. Let's distribute. There's an ab on both sides, so they cancel. Since a over b is equal to c over d, we can multiply this by c and d to see that AD is equal to BC, so we can cancel those out. Continuing in this manner, we eventually find that 0 is equal to 0, so we're done. 5.13 says that if A over B is equal to C over D, which is greater than E over F, then A over B is greater than E over F, which is self-evident. In 5.15, we take equal multiples A and B of C and D respectively. A over B is equal to NC over ND, where the n's cancel, so A over B is equal to C over D. In 5.16, if A over B is equal to C over D, then we can multiply and divide everything to opposite sides to see that the reciprocals are equal. 5.17. If we have A plus B over B equal to C plus D over D, we can split each fraction, and since B over B is equal to 1, same for D over D, B over B cancels with D over D, so A over B is equal to C over D. 5.18 is the converse of 5.17 and is clear from our work in 5.17. In 5.19, if A plus B over C plus D is equal to A over C, we can multiply both sides by C plus D, split the fraction on the right, divide out C, cancel the a's, and divide by d to find that b over d is equal to a over c. Skipping to 5.22 says that given a set of equal fractions, like so, We can substitute values in from the set until we find that the first numerators over the last denominators are equal. (5.23) is similar. Given these fractions in perturbed fashion, we substitute in values to arrive at the conclusion. (5.24) is again similar. Given these fractions, substitute in values to arrive at the conclusion. And finally, 5.25, if a over b is equal to c over d, where a is greater than the others and d is less than the others, then by 5.19, a minus c over b minus d is equal to a over b. A is greater than b, so a minus c is greater than b minus d. Add c and d to both sides shows that a plus d is greater than b plus c.